Yeah, it's pretty pathetic. Can you hear me? I don't know that I've really mastered this thing yet. Okay, give me a problem to do because I think I'll feel better if I just do some math problems. I'm going to integrate something here. Just waiting on my 2 viewers. Oh, please do, yeah. I'm glad you know what you're doing. Shout out to Emma Romeo, who is getting the class invited to this thing. Okay, I'll just integrate something random for now. Just for fun, that'll make me feel better. Alright, let's just do a simple cosine of 4x dx. Great. So we see that we have an outer function and we have an inner function. Okay. Now, outer function, cosine, inner function, 4x. Usually the inner function is the u. So we'll just pick u to be 4x. That means that the derivative of u is going to be 4 dx. Excellent. So we see the dx, right? We definitely do want that, which is right here. We don't want this 4 here. So we're going to divide it over just like this. Divide by 4, divide by 4. And that's good. So now we have du divided by 4. So du divided by 4, which is actually dx. And then we've got this integral, right? Integral. And that's of cosine of u, actually, at this point. It's cosine of u. We don't want that 1 over 4 there, so we'll just pull it out there. Now, integral of cosine of u du, you just treat it as if you're taking the integral of cosine of x dx, right? It's the same thing, it's just a different letter. So integral of cosine of x dx with a 1/4 is sine of x dx, right? Or sine of x plus c. So we got 1/4 sine of x plus c. Now the thing is, it wasn't really an x here, it was actually a u there. So this right here wasn't really an x, it's a u. So we know that the real deal is going to be 1/4 sine of 4x plus c. So that's the answer. And the cool thing about this is, since you're doing an integral, you can actually derive it to see if you get the right answer. So it's kind of cool because you can take your answer, which is this thing, and just take the derivative of it. So I'm going to take the derivative of this with respect to x, and I've got 1/4. The derivative of sine is cosine, and we'll leave the inside alone, and then we'll chain rule that guy. That's great. And the plus c, whatever that is, if it's a 9 or a 10 or whatever it was, it would go away. So that's gone, and we have cosine of 4x as our answer. What an exciting u substitution that was. Okay, so cool. Oh, we've had 7 people come into this stream. That's very exciting. All right, so I'm ready to do some math problems. I'm also going to try to eat some pizza while I do that, yeah. My wife ordered me a pizza because I was feeling pretty down. No, I'm not eating chips, but I'm going to be eating pizza in a few moments. Yeah. You want to say hi to Emma Romeo?
Oh, hi friends. Oh, it's Emma. Hi, Emma.
Yeah, it's really just one person.
Oh. Well, hopefully more return soon.
Oh yeah, I'm sure we're gonna be up to like 5,000 viewers pretty soon.
How many subs do you have?
Oh yeah, I've got a solid 70 subscribers now. Okay, I'm waiting for a math problem, so can somebody give me a math problem to do? Oh wow, we've got 2 viewers now. Hey, come say hello. Oh, 3 viewers. This is amazing. Oh, Emma says hi. Alright guys, let's do some math. We'll recover from my horrible afternoon. Tell you the story of that. Got a flat tire. Thought I would just pump it up and get there 10 minutes late. Pulled into the gas station to pump it up. And the tire was off of the rim. And the rim was destroyed, of course. So then I started to take off. Yeah, that's a bad thing. Pretty expensive. Remember, I've already spent quite a bit of money. We won't say the exact amount. Getting my car fixed because someone hit and run it in the road because I parked in front of my house. And that was not an at-fault accident, but it was unfortunate. Anyways, yeah, you had some optional homework. It was like, no, you didn't have any real homework. Anyways, back to my story. Then I'm trying to take the tire off, and I break the lug nuts. So I broke 3 of the lug nuts off, and the studs. So now there's nothing to like hold my tires on. So apparently I'm Ubering to school tomorrow. Okay, number 1 of the practice problems. I actually don't know what that problem is, but I can try to figure it out. Oh yeah, the practice thingamajigger. Alright. I'm hoping I have this on paper somewhere, otherwise you're gonna have to like, I don't know. Just type it all out.
Can they hear you? I mean, can you hear them?
No, I can't hear them, but they typed to me on the chat. I've currently got 3 viewers. 8 people have been in or out of this video.
Rude.
I think. I'm not an... Oh, my screen for stream. You want me to just make it the whole screen or like this? Get rid of the chat? But I can't really... I'm trying to see what you're saying. So, if that's any better.
Let me know when you're ready for it. Oh, yes.
I'm not sure if you're seeing exactly what I'm seeing. Let me go back and try to figure this out. Can you tell me that problem that you want me to do? Oh, okay, so it doesn't normally look like this, right? Oh, nice. This is brilliant. Using different type of technology. Thanks. Okay. Questions are pouring in from all over the country here. So, oh yeah, that looks terrible. Oh, that looks just awful. Okay. Plus, this isn't a question, but that's fine. Alright, so maybe I gotta do this or something? No, that doesn't help. That doesn't look good. Nope. Full screen this or something? Oh, that's not good. That didn't help. That didn't help things, I don't think. See, you didn't need to use these like encoder things back in the day, which is why it took me like so long to get this up and running. So if I do this, maybe. I don't understand this stuff. I really don't. Let me try to like right click it or something. See if it'll like full screen it or something. Screen, color, layout, effects, refresh. Yeah, now we just see like huge.
Like Inception.
Yeah, like Inception. What do you say? Maybe if I do that. Okay, so here's what I got anyways. Okay, I'm going to do a problem hopefully this looks a little bit better. I just like messed around with click some buttons randomly. Okay. Okay, this is exciting. Yeah, this is a great problem. Great question. Okay, you look at this problem and people think, geez, this is going to be tricky. I'm going to need to do U substitution, etc., etc. But one of the things you want to always try to do is just alter the integrand. Okay, the integrand is this guy right here, this whole dealio. So if you can make that into a better format, I don't know, into a better form, you'll be in good shape. So I have x plus 1 divided by x. So I would think of that as x over x plus 1 over x. And that's what's inside of the integral, right, dx. So that's kind of cool because now I have the integral of 1 plus 1 over x dx. And be aware that this is always like all multiplied by dx, but we don't do a good job of notating that usually. And now we're going to try to integrate this thing right here. This is our new integral. I mean, they're equivalent algebraically. So I just want the integral of 1. So I derived x to get 1. And the integral of 1 over x. Now this is a memorization thing. You just got to memorize that ln of x comes out to 1 over x. So ln of x is going to be the integral of 1 over x. And don't forget your plus c, of course. Now, why did we put this absolute value here? Because here's the deal. If I was to look at this 1 over x here, and I was to go down here and I was to say this is, let's say, for example, it's 1 over 3 or something, or it's 1 over negative 3. Well, if this is 1 over negative 3, there's no problem with that. 1 can be divided by negative 3. That's all good, right? But if there was a negative 3 here, we would have a problem. This whole thing would be undefined. It would kind of explode or blow up or something, and it wouldn't work out very well. So we just put those like absolute values in to kind of cover our bases. So that's how we do that problem. We just alter the integrand and then integrate something that's a little bit easier, hopefully. So hopefully that looks good. Oh, I came up with an idea. Let's see what I can do here. I'm trying to figure out how I can like mute my microphone or something. Okay, I'm ready for more math problems. Got my 4 viewers here. Excellent. Yeah, we're doing good here. Yeah, when you get in, everybody, just make sure you say hello in the chat so we know you're here. And we can answer your questions. I am eating pizza right now, so if you want to give me some, if you could give me some math problems to do or whatever, I'll stop doing that. Okay, I've been told to do the whole paper. I don't really have an issue with that. Just making sure. Oh, Raymond. Hello, Raymond. Shout out to you. We're doing some calculus here, Raymond. I think you could do some of this stuff, my friend. So if you want to, just follow along, check it out. Also, Raymond, you did a really good job on your quiz. I don't want to break any confidentiality here, but you crushed it, man. Oh, very cool. Okay, the screen's better. I think the screen's a little bit better. All right, so I'm doing another calculus problem here. We got the integral of e to the 2x divided by e to the 2x plus 1. Exciting. All right, here's the deal. I'm thinking there's a couple things I can do. I got a couple options for u here. I got u equals 2x. I could do that. I could try u equals e to the 2x. That's another option. And I got u equals e to the 2x plus 1. Sorry, is the pizza eating crunching? Is it crunching really loud on the video in your ears? Because I can mute it when I eat the pizza if you want. Just keep me posted, okay? Leave it in the comments. Okay, so doing this integral out, it's going to be pretty awesome. Here's the deal. I've got a binomial in the bottom, 2 terms, right? I've got this u. A lot of you are going to think to put u equals 2x and just start it out from that. Oh, we're doing some calculus, my friend, so just take a look if you like. So u equals 2x is what we're doing here, and we can we could try to work that problem and show how it's a dead end, or we could just kind of go through this. So I'm going to just try and I think I'm just going to try this one right here, this u equals. So if we look at this du now, we have 2e to the 2x, right? And that's pretty much good, dx. We divide by 2 on both sides, and we're good to go. So this right here, you can see this right here is showing up right here. It's the top of the I don't know what you want to call it. Fraction. Yeah, we'll call it a fraction. Anyhow, this is going to be pretty easy to integrate at this point. But I want to kind of show this road and why this is not the right road to go down. So let's just go through here and just kind of talk about the black writing, which is actually working out pretty well. The du has all of this stuff in it. So e to the 2x dx, that's all here in that du. Oh, do we got Jacob, Brandon here? Make sure you say hello, guys, if you're in. So now I got the du is going to have that e to the 2x dx in it, so that's all taken care of now, and it's just really 1 over u, which is e to the 2x plus 1. So you can see that all of this green stuff has changed over, right, to the black integral below. Now the black integral below is pretty easy. It's 1/2, and then we just talked about this ln of the absolute value of u plus c. So that gives me, I think, 1/2 ln of the absolute value of 2x plus c. Now this is the right answer, but I want to take you down another road. I want to talk to you about what happens if you were to take the u equals to 2x approach. Could it work? Maybe. I don't know. But it's not going to be fun. So I'm going to divide by 2 and just kind of see what happens here. So if this is the approach I take, and we know that this is the wrong approach, I'm just trying to give you that idea right now. And I'm going to erase this right now, so you can always scroll back if you need to. But I'm going to get rid of this. And we know this is the correct way, all the stuff I'm about to erase here. But now what we want to do, now the quiz is on like everything like skill-wise. So you want to be able to integrate anything known to man, basically. Be able to integrate lots of stuff. So we now have the integral of e to the u over e to the u plus 1. And we have this du over 2 here, right? Du over 2, and I'm going to bring that out as a 1/2. And this would be my new integral. So I guess what I'm saying is I replaced this integral, right, with this integral. And I want to ask you, like, does this look better? It's not really much better. You could theoretically do another u substitution to get to the end, but you would have saved yourself some time if you just went back and kind of looked at the problems that we did before. So preparing for this quiz on I guess we say 4.4 to 4.7, I'm not really trying to go back to like 4.1, which is like the summation stuff, right? And I'm not really trying to go back to all this like this kind of stuff, I squared, you know what I mean, all that deal. But oh hey Tim, welcome. Glad to have you aboard. I don't really want to go back to like even 4.2 and 4.3, which was like trapezoids, right? Trapezoids. They could be on there, of course. Any of those like upper and lower sums. So just left hand, right hand, upper, lower, they can be on there. I don't think I'd throw a summation on there. That's pretty like brutal if I did that. It's mostly skills. Can you integrate everything, basically? Ugly, ugly things, can you integrate them? Of course, there'll be a little more to it than that. Average value of function, perhaps, or maybe even some applications. But generally, we're just trying to like integrate everything. So I'm hoping that we get some more questions pouring in now. I know we've got some viewers here. Our average watch time is 2:57, so that's good. Some people hung around for a bit. Trying to do some more problems. So I'm going to go on to the next page, and I'm going to wait for some more questions to come in. And I'm also going to eat my pizza. So just hang tight while I do that. There's also some lag time, so you don't always hear what I'm saying until a little later. I'm not sure if any of you have ever had Buffalo Hawaiian pizza. That's what I'm trying right now. Buffalo chicken Hawaiian. Really good, I gotta say. So just that's another tip. That's another takeaway from this session. So we look at this problem right here. I'll do this problem while I'm waiting so I don't like totally waste your time. Here we go. Oops, sorry. Here we go. Okay. Yeah, we're talking buffalo chicken Hawaiian. I mean, that's pretty impressive. Buffalo chicken's excellent, but buffalo chicken Hawaiian. Best of both worlds. Okay, 2 pi integral from -1 to 0. I'm going on to the next one. It is not disgusting, Emma. It's really good. You got to try it. Don't knock it till you try it. Okay, so here's what we got going on. And we want to think about how to integrate this. Now you're thinking, should the u be the x plus 1, which is on the inside, or should the u be the x squared, which is 1 higher power, the function, not the derivative? So I would say it's debatable. You can think about it for a second while I eat a little bit more here. Haven't had any dinner. All right, so here's the deal. If you make u equal to x squared, let's just go down that road for a second. Let's just see what happens. This is what I got. Right? I'm going to rewrite this integral in a new, they call this change of variables. Instead of u substitution, you call it change of variables. U. But the problem is, like, now this stuff right here, this x plus 1, I don't know what to do with that. What is this x squared? So x would equal the square root of u, I guess. So it's like this, plus 1. And then there's like this dx. But dx has an x in it, right? So it doesn't work that well. So we're not going to go down this road. You can see it's not working out because the dx is now, like, you have the function and derivative, but they're one's outside, one's inside. So I'm going to take you down a different path. U equals x plus 1. This is where we want to be, plus 1. Du equals dx. So I've got 2 pi. You ever wonder why I always leave these numbers off? I want to tell you something that's kind of important here. It's not like the end of the world if you don't learn this, and we'll talk about it in class, but what they really like you to do is when you're doing this, they really would like you to change this 0, which is an x, right? Would you agree this is an x? Because everything's x up here. Well, they'd really like to change that into a u. So if x is 0, u is actually 0 plus 1, u is actually 1. And if x is negative 1, then u is actually 0. Negative 1 plus 1 is 0. So you can actually change this and put these back in as long as you change the way the numbers are. What I've been doing a lot of times in class is just leaving these limits off, the limits of integration. Shouldn't really do that. It's kind of frowned upon, but everyone kind of does in general. So it's just kind of the way the world works. So here's the deal. I've got this x squared. I don't know how to deal with that. I don't know how to account for that, so I'm just going to put it there. And then, let's see. Oh, yeah, so these are x's. Let's talk about why these are x's up here. These are x's because this whole integral has to do with x, right? It's just, this is a whole integral about x. Right? Everything in there. But then this is a whole integral about u. Although I haven't gotten there yet. I've got a u here, I've got a u there, right? I don't know what to do with that x squared. But I do know I have the square root of u du. So I'm pretty close to having everything in terms of u down here. So what we're doing is we're changing from x to u to make it easier to integrate. Because if we now, if the u has a whole bunch of stuff in it, it's just an easier looking integral. Problem with our integral in this bottom right here is that it has an x squared in it still. And we don't really know what to do with that. The only way I know how to handle that in this situation, maybe not the smartest way to do it, but is to get x from this. So I get x equals u minus 1. So if x equals u minus 1, then this should be replaced with u minus 1, and you can square it if you want. So we can just say this whole thing is replaced with u minus 1 squared. So what am I saying? I got 2 pi, the integral. I've changed these over to u's just for the heck of it. You could leave them off. It's going to be okay either way. This is u squared. I'm just foiling this out, minus 2u plus 1. And this is all times the square root of u du. So that's where we are. So let's talk about this one more time. We started with an integral that was all in x's. It was complicated. It didn't look good. It wasn't integratable. I don't know, integrable. I don't know. You couldn't integrate it. Let's put it that way. Everything was in terms of x, so we changed everything in terms of u, like down here in the left. So we went from x's to u's, and then, oh, I am sorry about that. That is unfortunate. But you know people stayed at Market 32, I think. A little crew there. 4 of them. So anyways, we're changing into u's, and then we change our integral over into u's. And we have this x squared that we couldn't get rid of, so we did this extra step, and now we've got it all into u's. And we even changed the, no, you don't have to worry about it. I would just leave them off the integral. This changing of the limits thing is really something to just be aware of for the future. Kind of cool to know, but not necessary. Because you can just leave them off the integral until the end when you put it back into x's and then do your work. So anyways, I've got this integral, and this doesn't look better. It really doesn't look better than what I started with, but it is better because you can just distribute this right here, and then you'll get a pretty decent integral. So I'm just going to work on this integral. It's not too bad. 2 pi. I have these things as 0 to 1 because they're u's again, remember, don't forget. You don't need to put these limits on while you're going through. I don't even think in the situation of the exam you'll need it, but there's occasionally they might have a multiple choice like that. It's kind of weird. So u to the 1/2 times u to the second. So we get u to the 1/2 times u to the second. So what we're doing is we're just adding exponents when we're doing this. So this is my first distribute. So let me just kind of color code here a little bit better. My first distribute is this, right? That's this guy. So that's u to the, I don't know, 5/2. U to the 5/2. Then I got this next distribute, and we're just going to add exponents every time. If you just remember that exponent rule, you'll be okay. Shouldn't have done red, should have done a different color for sure. Let's try green. So now my green distributive, that's negative 2u to the 1 and u to the 1/2. So u to the 1 and u to the 1/2 is u to the 3/2. It's negative 2 u to the 3/2. And that's not so bad. And then we're going to distribute again. And that'll be, I don't know, u to the 1/2. Just u to the 1/2. It's fine. And this is all du. But it's all multiplied by du. So that shouldn't be in blue, but it is. That's life. So we go on down and we integrate it. So I guess I'll go color by color. U to the, u to the 7/2 divided by 7/2, so multiplied by 2/7, minus 2 u to the 5/2 divided by 5/2, so multiplied by 2/5. I'm just going to kind of sneak it in there. Okay, so the x squared over here, wondering how I got rid of this. This red x squared, right, was a problem. It was not a good thing. It was like danger. Let's try to put it in some sort of, there we go. This x squared right here. It wasn't, we didn't want an x because we wanted an integral with just u's. So what I said was, okay, how am I going to figure this, this x squared out? And I'm going to take u and figure out what x is right here. So I'm doing this. So everything with the stars is with the stars, right? I figure x is equal to u minus 1. And so now I'm plugging in u minus 1 and just foiling it exactly. Thanks, Tim. So let's say that's good. You can always scroll back. This video is not going anywhere. And then I'm on to the blue part, I think, now. This is ugly, but I'll deal with it in a second. U to the 3/2. I'll figure out this lag time eventually, but for right now, I don't really know because I had to get an encoder for this. That's why it took me so long to get on here, and it was pretty annoying. It was kind of a frustrating day in general, but made it through. So we got 2 pi, and this is, by the way, another thing to just be aware of. Some people have been asking, when you integrate something, so see how this was had an integral, and now we've integrated it to this. Well, sometimes when I have all this stuff inside, it can be a little confusing. So sometimes what I do is I change the straight bar to straight brackets. So what I've done here is, instead of just having the usual straight bar, so you might have this thing, or whatever, we'll make that a 0. Instead of having that, I'm doing the same thing, but just making them straight brackets, right? I've integrated, they're gone, and I'm going to plug in. Now, here's what's cool, actually. Tim might find this kind of interesting. You don't actually have to change back into u's. Thank you for looking out. Yeah, it was brutal. The car thing was kind of put a damper on my day, but I'm recovering. And I've got, good pizza here, and my wife was really nice to me because she knows I'm upset. So we can just plug in the u's and actually be done with this. This is kind of a crazy thing, but you'll find this kind of to be cool, and you might even try to pull it off later. I don't know on the quiz, but this is still u to the 1, and u is equal to 1, and u is equal to 0. So this is just a random thing that I just did to kind of show you the notation. See how I made a straight a bracket instead of a straight bar, because I don't want this 2 pi to get stuck with the red term and not distribute out to all the other terms. So I put straight brackets in to show that all of this stuff is going on. Okay? Yeah, we need to get some likes for sure. So what's kind of cool about this is, I don't even know where to find my likes, but glad to have you join us, Kyle. Glad to have you join us. So we're checking out this thing here. And here's what's cool. I changed those variables over. Kyle, I'm not sure if you were here for this, but we changed the x limits into u limits. Pretty cool. Don't have to know how to do it for tomorrow, but it's pretty nifty. And now that we've done that, trying to get rid of this thing. Now that we've done that, because we started with an integral that had x is 0 and x is -1, whoops, x is 0 and x is -1. Now we change them over because we know the x's can change to u's, so we have 0 to 1 here. We can simply plug in. We don't have to change back to x. Kind of cool. So we got 2 pi. These are kind of just like distributed property. We can just plug in 1 for all these things. So we got 2 7s minus 2, actually minus 4 fifths, right? I'm not very good with this tablet thing either. Minus 4 fifths plus 2/3, all that stuff. And what I like to do here is when I'm doing this subtracting this thing, I like to do subtract and then show all the things I'm subtracting, and then all of this is multiplied by 2 pi. But since I'm plugging in 0 for u each time, all of these things are going to go to 0. Now watch out. This being 0, if it's trig, doesn't make all of this stuff go to 0. This being 0, if it's like logs, for example, or something like that, doesn't make all of this go to 0. So watch out. It doesn't always work this way. But in this case, all of this stuff is going to be 0 when I plug in the 0. I didn't change back to x. I'm simply just plugging in the limits on that u thing because I don't need to change back to x, which is kind of cool. I don't feel like doing this algebra out, so I'm just going to show you. This is a parenthesis or a bracket. It's all the same now, kind of. Ugh, not good with this thing. Yeah, exactly. It does make it much easier. But it's also, can be tricky to change the limits over. But once you see how to do it, yeah, you can save yourself a little bit of headaches, for sure. So I'm just going to leave it like that. This is our answer. You'll get the same answer if you change the limits back to x's. If you change the limits back to x's and then plug in those x's. So if you could gone back from u to x and then plugged in. So that's kind of cool. So that's the answer. That's where we're at. And I'm hoping you can kind of keep up. Oh, yeah, I don't know. I wonder if I can like my own feed. I got 5 likes. It's pretty good. We're getting there. Interesting. Okay, we're getting there, guys. We're doing good. We got 5 viewers, so that's exciting. Trying to find out where these viewers are. I don't know how to find out who they are, but that's okay. So there's that problem. Emma says I just got to do all of them. Can anybody release me of having to do every single problem on the worksheet? And possibly I could do, I don't know, particular ones that you found difficult? Like 7, 8, 9, I don't know, average value. Sometimes people, they slack off on that. Guys, I got to eat a little more pizza. Okay, now I got to do 4 because I did 1, 2, and 3. So here I go to do 4. All right. A plus 1 over A. You can't make me do 4 because if we look at 4, okay, here's what's kind of funny. I'm not sure if you're joking or not, but oh boy. If you look at 4, right, it's A plus 1 over A dA. Now I know it's A's. That's a little stressful, but let's take a second here, okay? I'm going to flip back a couple pages, and I'm going to look at this problem right here. Check it out. This one right here in the blue box, check it out, looks a whole lot like this one. So you do it the exact same way. The A's are X's. You cool with that? 8 it is. We'll check out 8. Number 8. Average value. Okay, average value is not as bad as you think. You just do everything you would normally do. You integrate. You get the area under the curve. And then you divide by the width of that area. Divide by the width of that area. So you just kind of subtract the limits of integration or whatever to get the width of the area. Hold 1 second. I don't know if I can pause this thing, but I'll be back in 2 seconds. Okay, cool. Had to turn the heat on. Getting a little chilly in here. Yeah, I had to make that happen. So average value. We know that if we had a bar, the way we find the area of the bar, is we would do the base times the height, or the width of the bar times the height of the bar. Either way. So width of the bar times the height of the bar. In this situation, we don't have any bars going on here. We just have, well, let me get the problem. We have area and we have width, obviously. So let me show you that. 3x minus x squared. Okay. This is a good one. Y equals 3x minus x squared. Okay, we want the average value of that thing in the first quadrant. So we might want to draw it, but what I do want you to realize is, like, when we take a graph, okay, let's just take a quick graph here. Throw an idea at this thing for a moment. We look at any graph, okay? Not the best. Not my best. Okay, we look at a graph and we say, okay, here's what's going on with this thing, okay? This is the graph. And it goes from here, 8, let's say, to 1. And we want to say, hey, what was the average value of this graph? Well, we can kind of like look at it and say, like, okay, well, it's lower here and it's higher here and then it's higher here. And we kind of say, like, the average of this height of this graph is like maybe, I'm trying to draw a straight line. It's not working out. The average height of this graph is maybe somewhere around like here. I don't know. I think that's maybe a little low. So I will move it. See how some of the stuff is below the graph, right? And some of the stuff is above it. We're saying this is the average height of the graph. Well, the way that we could find this is we could just take the area under the graph, which is all of this, even to here, even inside the mountain, all of this stuff. This area under this graph, whatever that area is, okay? And we would divide it by the width of this region, which is 7, 8 minus 1. That's not a 3, it's a 7. So if we just take the area and divide it by the width, we'll get the height. Because area equals width times height. That's the concept. You're trying to find the average height of the function. If they say average velocity, you can integrate velocity and divide by how long it was. If they say average position, you could integrate position and divide by how long it was. Anything like that, because it's average value of the position function or average value of the velocity function, and so on and so forth. All right, let's graph this thing. So it's 3x minus x squared, so I like to set it equal to 0 to like, I like to set it equal to 0 just so I can see where the roots are or whatever it is, you know. So I got x equals 0 for a root, and I got x equals 3 for a root. So x equals 0 is a root and x equals 3, so we know that there's a root here and there's a root here at 3. We know it's an upside down parabola, so it's probably going to look something like this, some odd like this, and we'll make that 3 and this 1. So what do we want to do? Well, what we want to do is we want to find the area inside of here, this area, and we want to divide it by 2 because it's 2y. Oh, sorry, 3 because that's actually not a 1, it's a 0. We want to divide it by 3 because that's how wide this region is. And when we do that, obviously we'll have an area here, but we'll get the average height of the function from this time. So we want to kind of like get an idea of where that is. So that's probably like, you know, right around here, right? We see that it's a little bit below here, it's higher here, it's higher here, it's lower there. We want to know what's the average height of that line. Sometimes it's on 0, sometimes it's way up here, sometimes it's down here. What's the average? Well, the average is probably somewhere in here, right? The average height of that line. Okay, so what's the deal? We really just need to integrate from the start of the region to the end of the region. Why did I go from 0 to 3? Because we got to be in the first quadrant. We can't go down here, we can't go over here, and then the parabola is never going to come back. It's a parabola, guys. So we just want to integrate this thing from 0 to 3, right? Now, the book will always say like 1 over b minus a, right? They're going to say 1 over b minus a, 3 minus 0, right? And 1 over 3 minus 0 is 1/3, right? That's fine. you can do that if you want, but I'm always going to say if it's 1 over b minus a, it's 1 over 3 in this situation. I'm just going to say this is the area and this is the width, right? So area divided by width is the average height. So all I'm going to do is I'm going to do out this whole entire math problem in red, and then I'm going to divide my answer by 3. If you want to do 1 over b minus a, which is 3 minus 0, 1/3, that's the same as dividing by 3. That's okay. So I got 3x squared over 2 minus x to the 3rd over 3. And I can use the bar in this situation from 3 to 0. And we have to make sure we divide by 3 at the end. Ugly. Let's try to fix that. If you want to put 1/3 in front, that's okay. And remember, this is a 3 here, even though it does not look like it. So then it's just computation, right? We got 27 over 2 minus, I think 81 over 3. I could be wrong, but I think 3, that's 9. Nah, actually, no, I think that's still 27 over 3. Okay, my bad. So 27 over 2 minus 27 over 3. And then we have to subtract out the 0 thing, right? But like, we got 0 over 2 minus, yes, what do I need to wait for? I got 0 over 2 minus 0 over 3. And that really is just 0, and we're going to divide this all by 3. We don't need to use a u sub in this situation, actually, it turns out. So you're in luck. Isn't that exciting? So since I'm dividing by 3, I'm just going to say that this is 27/6. And this is 27/9, I guess. 27 over 6 must be 13 over 3. 27 divided by 9 is just straight up 3. Which I guess is 9 over 3. So that's 4 over 3. And I believe that's it. So the reason you don't need a u sub on this one is because, like, if you look at the original, if you look at the integral here, like if you look at this stuff in here, it's just a nice little polynomial, right? There's not like an inside, outside. This is one you could anti-derive for a while. So you're good to go on this one. Even though maybe you look at a function and its derivative, but it's not, it's a product or like an inner and an outer. You got to watch out for the u substitution. So products are often u substitutions. Function and its derivative, sure. Inside, outside, definitely. Those kind of things. So that's kind of where we're at with that. So I'm ready for more questions. I don't know how long we've been doing this, but I could keep going. I feel bad I wasn't able to make it tonight. Just going to mute this for a moment. Alright. Average value is like not too bad. You just got to remember to divide by the width of the region. I mean, if you know you're integrating something, you can integrate it, right? Use a u substitution, use whatever you need. But then just divide by the width. So you can do b minus a. So this example number 9 here on this paper says find the average value of sine of x from pi over 4 to pi over 2. So like if it's the average value of sine of x, whoops, oh well, from pi over 4 to pi over 2, well, the width is going to be pi over 2. So we're just going to divide our answer by pi over 2. We're going to integrate it and divide our answer by pi over 2. So try to find a tricky one, right? Try to find a tricky integral for me to do, a tricky u substitution, a pretty annoying one. Meanwhile, I'm just going to show you this particular solution thing. I think this one's on the paper as number 7. So this is a differential equation. So I got f prime of x. You're finding me a hard u substitution, hopefully an annoying one. And I want to solve the differential equation, and I want it to satisfy this condition. F of 1 is equal to 12. Well, at the end of the day, that's x is 1 and y is 12, right? X is 1 and y is 12. I like to kind of look at that as that way. So this is like for later. We're going to do this later. You like that? Right now what I'm just going to try to do is just try to find what f of x is. Well, and kind of integrate both sides. If I integrate f prime, I get f. If I integrate this thing, I'm pretty good at doing these in my head, obviously, so I'm just going to kind of x to the 1/2, so it's going to be x to the 3/2, divided by 3/2, which is multiplied by 2/3. So it's really 8/3 x root x. It'd be good to memorize that x to the 3/2 is x root x. That's something I would love for you to have memorized. You may not have memorized it, but x to the 3/2 is x root x. So this is what we got, plus c obviously, and that's what f of x is. I'm just going to call it y now. I'm going to call it y. So y equals all of this. Here's the deal. We got this green thing says later, and we know we have an x of 1, so 1 root 1. And we know we have a y of 12, so 12. Everything else stays the same, so I'll go back to the blue for that. At 8/3, 1 root 1 plus c. So it's really just 8/3 plus c is equal to 12. So I don't know, how are we going to get 12? Well, we need 36 over 3. So we need 8 plus something to get 36. So I'd say, can you send that on remind if possible? That problem, like a snapshot. So 36 over 3 would be the best. So if I want 36 over 3, I think I need 28 over 3 here. So c would be 28 over 3 here in this case. I just solved that simple equation. So c is 28 over 3. Now what I'm going to do is I'm just going to take that blue f of x right there, right? And I'm going to rewrite it as the following. F of x, this is called the general solution, and this is called the particular solution or the exact solution, okay? They're usually going to say particular. So general solution is actually, well, sorry, the general solution is right here because it has the plus c on it, right? And then the particular solution has no plus c on it. So the particular solution is the following. It is 8/3 x root x plus 28 over 3. And hopefully there are no mistakes because it kind of comes out to an ugly looking thing. But that is solving a particular solution. So u substitution with long division is what I've been asked to try out. So let's see what I got here. I don't have a picture to go off of actually. Let me go through. But I can make up one with long division if that doesn't come through. See if you can get it to me. Alright. Let's make it like kind of not so bad. Whoops. Ugly. Yes. It's good pizza. Also got potato skins. This is like just comfort food because I'm really upset that I broke the lug nuts off of my car. if you joined us just recently, you didn't know that I broke 3 lug nuts off of my car today. It's now not drivable. I'll probably be Ubering to work tomorrow. Not exciting. So I got 2. Oh, that didn't work. All right, I got 2x plus 1 that I need to divide into x to the third plus 3x. But like, how do I know that? Because people always say like it's not really that calculus that's hard, or like what I need to do. But it's like, how do I know that? So here's the deal. You know the bottom is a 2-term thing. We don't like that. So you can obviously make the u equal to that. But if you do that, you're not going to get an x to the third in your du. So you're going to have to figure out this x to the third somehow. Then you have to solve this for x, right? You get u minus 1 divided by 2 to solve this for x. Then you're going to have to cube that to replace this. And then you're going to have to plug in something nasty to replace this. It would just kind of be a mess. You don't really want that. So it's not going to work. But if you just long divide it, it will be a lot better. It will be a lot better. So let me see what we got here. I don't know. That's not working either. Trying to get, oh, there we go. I got that picture out. Okay, cool. So u substitution is not the way to go in this situation. I mean, you can try it, and it leads you down dead end, but it's not the way to go. So it's 2x plus 1 we want to divide into x to the third plus 3x. Okay? Is anybody still here except for Emma and Tim? Who else is here? Say hello in the chat if you're here. Oh. Okay. So I got Emma and Tim. This deal right here is what we're working on. 1/2 x squared. So 1/2 x squared times 2x. We're really looking at the first. Oh, I got Emma Tauber and Kyle Tauber. Excellent. Hey guys, glad to have you. That is a serious delay on this. Okay, 1/2 times 2, that's going to cancel out. We want to get x to the third, so we know that we don't want 2x to the third, so we need this 1/2 to kill the 2, and etc. So what's happening in long division, I'll go a little slower, is to do this. You distribute it, right? So I got Jill is here. Jill, say hello as well. So we got 2x times 1/2 x squared, so I guess that's just x to the third with that distributing. And then this is going to be, it's going to be a mess. It's going to be 1/2 x squared. I made this problem up, so it may come out horrible. We're subtracting. That's gone. And we wind up with, I don't know, these don't even really work out. We get minus 1/2 x squared plus 3x. Okay. So now we want to divide the 2x into that. How do we do it? I think we need a negative 1/4 here. We multiply by 2, we get negative 1/2, and we'll need x. That's what I'm thinking. So I'm going to multiply this out now. I guess I'll use a different color and distribute again. So now we'll distribute with blue, let's say. Sorry for this. Pretty horrible. I'm not used to using this like tablet thing that I'm using. So I got 1/4 of, I got negative 1/2 x squared minus 1/4 x. And then I'm going to subtract, so I'm really going to add. So I'm subtracting negatives. Gone, gone. 3x minus 1/4, I don't know, 2 3/4 x. Weird that it's a mixed number, but it works. And then that needs to be divided. So it's coming out really ugly, right? But let's just say this came out a little bit nicer. So I'm going to make a little change here, okay? Just a little change. I'm cheating right now, but I made this problem up. Instead of this coming out to all this, let's just say it came out to 2, okay? So what would you have? Well, once you long divided, you'd have 1/2 x squared minus 1/4 x. I'm looking at the top there, plus 2. Remainder is the 2, and then 2x plus 1 is the divisor. So this is now the integral you need to solve. This is not really too bad of an integral to solve. Remember, I did cheat. I just kind of changed this so that the numbers come out nice. Remainder over divisor. This can be integrated easily, so let's just kind of go through the checklist. I'm just going to say you know how to integrate that. You know how to integrate that. This, I mean, it's not that bad because it's really just we're doing a separate integral here of this one, right? Here's a u sub, a quick u sub, a quick and easy u sub, but we want the u to be the bottom. So we make u equal 2x plus 1. And then our du would equal 2 dx, which is kind of good. And so we'd have a quick little integration. I'm skipping around a little bit here. I'm just trying to give you the gist, plus c. So that's, this whole deal would come out to that. Sorry it looks ugly, but that's the gist. And the other two things with the red check marks to the bottom left, you know how to integrate those so they'd go well. Oh, sorry, apparently I didn't put my microphone into the right place. Cool. So hopefully this is making sense. I don't know what that emoji means. I'm hoping that means yay, like you understand how to do the math now. I could be wrong. All right. So I did a few of those. Tim was talking about just like how to determine when long division is necessary. So when I look at this initial problem right here, because that's what he's asking about, how do I know long division is necessary? Well, I look at this problem and I say, I got a couple options. I can try to make it into a bunch of fractions, but the denominator is 2 terms. So it's not going to be better. My only option other than dividing is to make the u the denominator. U equals 2x plus 1. Yeah, this isn't a podcast. This is a YouTube Live. We are way above a podcast. Oh, jeez. So we make the u equal to 2x plus 1, and then du would be 2x, 2dx or something like that, but it just wouldn't work out. And we kind of talked about that, Tim. I think we kind of covered that. I'm looking at this problem right here, another like real quick one, and I might not do it all out because I did this whole one out, sort of. But this is an integral. It's number 15 on, I think it's on page 351, I believe. It's whatever page was sent to me. So let's say at 351. It's the integral of x squared minus 3x plus 2 over x plus 1 dx. So look at it, right? Try to factor it if you want, but it won't work. It won't cancel out. The bottom is 2 terms. That's a big reason it's long division, because otherwise you could make it 3 different fractions if it was like if it was over a monomial instead of a binomial, but it's not. So long division will make this look better, and hopefully we know how to long divide it. Can you guys give me a word in the comment as to whether I need to do this problem? I'm hoping I don't, and maybe give me a couple more, and pretty soon I might be trying to wrap things up here, people. I don't know how long I've been on. I don't know how long I've been on here, but oh yeah, solid hour and 4. Okay, cool. Do I need to do this problem, or can I go and do a different problem now? How about like these ln of x ones? I'm sure you love those. Like on page 351, cool. On 351, there's like 21 and 22, 23, 24, 25, all those ones. I don't know if those are something we need to do, or maybe a trig. Maybe even an integral. Maybe even an integral of something like. What one do you want me to do one of? You're just talking about those numbers. Maybe an integral of like a reciprocal ones. So you want me to do an ln? Is that what everyone's saying? Can you just type ln if that's what you want me to do? Or are you saying just a random other problem? So let's say ln. I don't know. I see this one here. Looks decently hard. 22. Let me know if this is what you're talking about. 1 over x ln x cubed. Thanks, guys. That is helpful. Okay, that's an x, not a t, but it looks like a t, so we'll change that over. All right, let's talk first what our options are. What could we do, potentially? So I'm just going to list out our options. We could obviously make u equal x to the third. And that's an option. We could clearly try u is equal to ln of x to the third. I don't really see another option that's going to work out nice. So I'm thinking we should go with that. I'm thinking we should go with that ln of x to the third. Now my other concern is the way they wrote it in the book seems like it's ln of x to the third, the way I wrote it in green here. I'm just a little nervous because honestly right now I'm thinking about this problem and I'm kind of scared of it. But we'll make it happen. Okay, so du would equal, let's just find out, 3x squared over x to the third dx. There's some good news here, guys. Check out the 3x squared and the x to the third. 2 of the x's are going to go away, so we're going to have 3 over x dx. That's what du equals. So if I was to divide by 3, I'd have just 1 over x dx, which is, oops, sorry, bad habit, that. So what I'm saying to you is this 1 over x dx is going to be taken care of right now by the du over 3. So that's done. So that's gone. That's gone. Great. Now we've got another one. What do we got? We got ln of x to the third. Well, we know that our u was ln of x to the third, so it's just 1 over u, right? 1 over u. 1 over u du. I got 1/3 on the outside. So I got 1/3 ln of the absolute value of u plus c, which is 1/3. Now you'll notice you have to go back to x's when you're doing integration without any limits, and that's why I always teach you how to go back to x's, because you have to be able to do that. This is a weird one. It's the ln of, right? Because ln of u, but u is ln of x to the third. So kind of weird, but ln of x to the third plus c. And that would be our answer. Ideally, you could derive that. Kind of ugly, a couple of chain rules going on there. And it will come out to the integrand, the original function we're trying to integrate. I forget what else I was saying. Oh, I was saying that when you don't have the numbers here, the limits, right, you can't change them to u's and just be done. You have to always go back to x's whenever you're doing an indefinite integral. So people were asking, I think, the terminology. This is an indefinite integral. This is an indefinite integral, right? But if I want to show you a definite integral, I'm sure you can kind of figure out what's going to happen here. This is an indefinite integral, right? And this is a definite integral, 0 to 3. So we see the difference. And if you guys can leave some comments on how I'm doing, if I can wrap it up here, that'd be good. Oh, no, you don't want to do that. Well, I had a stressful weekend as well, so I hear that. So you see what I'm saying. We got this definite integral here because we have the numbers. So indefinite integral has no numbers. Definite integral has the numbers. And if you joined us late, you can go back and see I did a cool thing with a definite integral with the u's. So we'll wrap it up there, and I'll see you guys in class. I think we have a quiz first thing in the morning, and I think obviously the live video gets posted and saved, so you can always check that out. Yeah, make sure you like and subscribe. We were trying to get to 7 likes here, people, but we're only at 5. I know we have some viewers on here. If you could just like, we're trying to get to 7 likes. That's our goal for today. So if you could like, I can wrap up this video. So yeah, that's a good solid hour and 10 minutes. So that's there anytime you need to see it. And we will talk to you soon. Peace.